So, welcome to my static analysis of spy eye Trojan. And in this video, we'll be analyzing spy eye Trojan using static analysis. First, we download the spy eye executable on GitHub, and then we use the Exeinfo. Exeinfo shows general information about the executable file. It shows if the malware is obfuscated, packed to prevent detection from antivirus. And these two assist in providing information about unpacking the malware. So we copy, we drag and we drop it, and now you see that is packed with AS pack. And it also provides information on how to unpack it, as you can see, as I've highlighted it. That is how to unpack it and also provide other information. So the next step now is using PeStudio. PeStudio helps to find suspicious artifacts within an executable file, such as the PE header, indicator strings, import libraries. And now you can see we have the footprint yet. With this footprint, we can be able to know what type of malware it is. We have the AS packed version 2. That is the version that it was packed. We have the timestamps, and we also have the file type, the path. So its timestamps are used when malware authors compile the date and the time that the malware was compiled. So it's important that you know the timestamp. And embedded in PeStudio is VirusTotal. So with VirusTotal, you can be able to see if it's an actual malware. Now, the suspect binary proves that it's a malware and it's a Trojan malware. Static analysis is not completely accurate because you can see that there are some antivirus that does not detect that it's a malware. And these are the antivirus that you must protect yourself from purchasing online because they cannot prevent Trojan attacks. We can also go www.virustotal.com, the GUI interface, and upload it directly, copy and paste the URL link, or copy and paste the hash values there, and it's still going to bring out the same information. So as you can see, it provides information that it's it's malicious, and it provides that it's a Trojan. It provides the packing information, it provides the file type information, and that's the use of VirusTotal. VirusTotal is very important and useful information for malware and malware. And you have to prevent yourself from purchasing all these antivirus that is undetected, because it's the undetected antivirus shows that it is a vulnerability, and this malware can attack those systems. So after that information, we also can get other information about the indicators. You see the sections there. We have the .text section, the .data section, the iData, and these are the common section except for the AS pack which is there. With the AS pack shows that it's compiled, which is suspicious. It shows the file type, executable type, which is executable. It shows the hash SHA-256 hash, which you can check on VirusTotal to check if it is a malicious hash. But here we see that because it is packed, it's preventing it from showing that it's malicious. Being that it's packed, the packed version is preventing it from being malicious. Now we see the footprint. These are all hashes, and these hashes you can copy and paste it on VirusTotal to check if it's malicious or not. This is also another method of checking if a application, a link, or any hash is malicious or not. But as a result that is packed is showing here that it's not malicious because it's preventing. This is the obfuscation method that malware cyber attackers use to prevent the malware from being detected. Those are the hashes that as you can see for different resources, different sections, they all have their own individual hashes. You can try it copy and paste the hash and see what result to come out. I expected no result to come out because it's packed, and being that it's packed is avoiding, is hiding, is preventing it from being detected. The other information you can find on the PeStudio, DOS information, you can find the file header, you can find the uh, the information about the file stamps, the directory information. You can see here Spark is still showing more information that's packed over there. You can find more information about the sections. Like we said, the sections, they are dot data, our data, resource, I data, e data. And for sections, some malware authors can create sections where they can hide some of the resources that the malware will use to operate to function. As you can see, that .aspack is a section that was created by the malware author, and it's not a genuine section. And now these are the libraries. With the libraries, you can be able to see the DLL that it's going to use to perform its attack. And these libraries, it provide information that it's being loaded into the memory where the malware is executed. The same thing goes with the imports. Import provide evidence if the malware is obfuscated. Having a few imports shows that it is suspicious because imports are usually a lot. So when it's few imports like what is showing up, it shows that it's suspicious. And then the resources, we have resources also, we have the ashes, we have the footprint, we have the ashes as well, which you can see there. And the resources also provide information. It stores resources that can be used by the malware, such as strings and additional files. And you can see it showing there that it's back PNG showing some useful resources. One thing you need to understand also is that the strings, malware authors often obfuscate strings to avoid detection, and strings provide information about the activities of the malware. They provide information about the binary that is stored, and it's usually either ASCII or Unicode because it's strings. Not all the activities are readable, but we can see that some of the activities here are readable. And being that it's readable, you can be able to understand that it's a malware. This program cannot be run in DOS mode. It shows that it's a malware because most malware, most executable always have that information. And now you can see that this part is unreadable. It's quite unreadable now because it's strings. Yeah, it all means something. But being that it's strings, it's making it unreadable for the malware analyst to understand is what is happening, on the malware. So it's really important that you carefully go through it and check what you can read out of it, as it's always providing information about what is happening or what the malware has done on the system. As you can see there, it shows information about the spy builder information. It shows information about the spy corporation, about the spy there. You see, it's a boat. You see, it's a boat and likes like that. And then we talk about the resource hacker. Often, attackers store information such as additional binary, decoy document, configuration data in the resource hacker. Now, the resource hacker can reveal information about the origin, the company name, the program author, details, and copyright information. And the resource hacker can also help to identify the file type if the file type is a decoy. As you know, some file type can be executable, can be Word or PDF or Excel sheet, but it's really indeed an executable file. As you can see, there is no binary, there is no this information here on spy high because it's packed, and because it's packed, it's obfuscating information from being shown. You see a lot of binaries there, but there are no informations on it. So I'll be running another malware to show an example of the kind of informations that you will see on a resource hacker when the resource when the malware is not packed. So I'll be running it so you will find the information about it. So this is very important that you understand the static analysis tools and you're able to use it in your analysis. Now I've run the malware on it. Now this is bitmap. As you can see, it has an image here. This is the icon, image of the icon. Now this is more information about what is being stored in the resource. You see, it has information about the control. It has information about you need to have the following the volume up. It has information about the get password, which means that it's going to request for a password, and this password can be saved by the cyber attacker, as well as the license. It has information about the license. It has information about renaming. It can rename, replace file. It has other information about select destination folder, extracting, unexpected end of archive. The archive comment header is corrupt, is creating file, wrong password, CRC field in the encryption, corrupt file, or wrong password. These are all binary being stored in the file, which shows that this file is a malicious file. Because if it's a legit file, all this information would not be on it. If it's a Word document, for instance, you would not see all these binaries on it. So it's very important that you understand how to run a static analysis to prevent and to protect yourself from if from cyber attackers using your information for malicious uh, and stealing your information. So this is about static analysis, and in the next video I'll be taking you through dynamic analysis. Stay tuned. Thank you.